Example 2. Some researchers were interested in comparing the sleep habits of U.S. adults. So specifically, they wanted to compare the percent who obtained 7 or more hours of sleep per night between two groups of adults, 18 to 29-year-olds versus the 30 to 44-year-olds. Suppose they obtained a simple random sample of adults in the U.S., and the results for the two studied groups are shown below in the table. Run a 95% confidence interval to determine if the difference is due to random chance. So our first group is 1829. We have 876. And then the percent with 7 or more hours of sleep is 58.8%. The next demographic group is 30 to 44 years old. And that N is 1177 with a percent with 7 or more hours of sleep at 55.3%. So again, we're going to verify our conditions. Simple random sample. That one looks good. Less than 10% of the total population. That looks good. The groups are independent. And our large count condition, we do 876 times 0.58, that's bigger than 10. 876 times 1 minus 0.58, that's bigger than 10. And same with the next sample, 1177 times 0.553 is bigger than 10. 1177 times 1 minus 0.553 is bigger than 10. We're going to use technology, so press Stat, scroll to Test, select B, 2-prop Z interval. On step 2, we're going to input x1 in 1, x2 in 2, and select the confidence interval. So note you're going to need to multiply 0.588 times the 876 and 0.553 times 1177 to get x1 and x2 respectively. And you'll need to round as well. And you should see the interval display. So our interval is negative 0.0084 to 0.078. And because it contains 0, this difference of about 3.5% could be due to random chance. Example 3. 2 types of medication for hives are being tested to determine if there's a difference in proportion of adult patient reactions. So 24 out of a random sample of 200 adults given medication A still had hives 30 minutes after taking the medication. 12 out of another random sample of 200 adults given medication B still had hives after 30 minutes after taking the medication. So create a 99% confidence interval for the difference. Again, we're going to verify the conditions. Simple random sample. That one looks good. Assume that's okay. Certainly less than 10% of the whole population. Groups are independent. And our count condition, N1 times P1 bigger than 10. So 200 times 0.12 is bigger than 10. 200 times 1 minus 0.12 is bigger than 10. 200 times 0.06 is bigger than 10. And 200 times 1 minus 0.06 is bigger than 10. We're going to go ahead and run our test, our interval. So we go to Stat, go to Test, select B, 2-prop Z interval. Step 2, input the x1 in 1, x2 in 2, and then select the confidence interval and calculate. So our interval is negative 1.33 to 13.33%. Because it contains 0, this difference of about 6% or so could be due to random chance. So even though medication A had double the number of patients who still had hives, this difference still could have occurred by random chance. So if you're taking the AP exam, you can work these out by hand as an example 1 or use the calculator. Be sure if you're using the calculator that you write down which test you use. This will be the 2-prop Z interval along with the interval interpretation. So in general, our solution would look something like this. So even if you're not taking the AP, you just have a regular statistics course, you're looking through this, this is a good rule of thumb for that class as well. So you state the name of the confidence interval, you verify the conditions, either do the calculation by hand, you can see example 1 for that, use a calculator, write down the interval, interpret the interval, and then state any conclusion that was asked.